Hey, welcome back to the lecture. So now let's see some more use cases of static storage class specifier. So a C project can be a collection of multiple source files, right? A project may be having many source files such as, let's say, file 1.c, file 2.c, file 3.c, etc. So now some files may be written by you and some files may be written by someone else who is part of the project. In this case, a static storage class specifier can be used to manage the visibility of the variables across various files effectively. Let's see how. Alright, so now let me demonstrate another usage of static. So when a project contains multiple files. So here I have a project. The project name is static underscore one, and it has one file that is main.c. Let's create another file, new file, and let me give the file name as, let's say, file1.c. So in file1.c, I'm going to create one function, a void function. Let me create a function here. Void, let's say, file1 underscore my function one. So an empty function. Let's go to the main.c. And here, what I'm going to do is I'm going to create one global variable. Let's say int private data. So now let's say this data is private to the main.c. So now let me initialize this data here. Let me initialize that to, let's say, 100. And after that, let me print that data. And after that, what I'm going to do is I'm going to call this function from main. So remember what I said was this data, which is type of int, is private to the main.c. So that means main.c expects that this data should not be modified outside the scope of this file. So but in file1.c, we can modify this data, right? So what I can do is I can simply change its value. So let me change it to 900. That's possible because this is global to the whole project. That means its visibility is to all the files of the project. Let's try to compile. Let's see what happens. Here we may get a couple of errors. So let's see what are the errors. First of all, first compiler tried to compile main.c and it met with an error here. Implicit declaration of function. So basically compiler is saying that it couldn't able to find the declaration or prototype of this function, which is defined somewhere else in the project, right? So that's why it's our duty to give the function prototype of this function. Let's copy this name and let's copy this and go to the main.c, go to the global section here. And just to make the compiler happy, so let's give the prototype. This is a prototype. Let's try to compile. Let's see what happens. So main.c compiled fine, no problem with the main.c. Now the problem is in file1.c where the compiler is complaining that this is undeclared. So that's why you have to give the declaration now, not definition, remember, because it is already defined here, right? So you have to declare that it is there somewhere. We do that by using extern. Extern int private data. So this is a declaration. Before modifying that variable, so we have to declare the compiler that it is there somewhere else in the project. After that, let me print this printf statement once again after this line. Let me try to compile. Let's see what happens. Right, so here it is. The first the value was 100, and after that you called this function which is there in file1.c, and file1.c can simply extern that variable and it can modify it, right? So that's why when you do this printf, it printed 900. That means the value is modified. But main.c wanted no one to touch that variable outside the scope of this file. So that means if main.c wants to keep this variable private to this file, then it has to use the static keyword here. So now this is accessible only inside the scope of this file, that is main.c, and it cannot be accessed from outside the scope of this file. Let's try to compile. Let's see what happens. Here you can see that compiler is not letting file1.c to modify this value. It is throwing error. The project compilation is not successful, right? So it is saying that undefined reference to this data. In real project implementation, let's say main.c may be implemented by you and file1.c may be implemented by some other developer. And if you want to put such restrictions, then you can use the static keyword. So that means this is kind of imposing privacy to your global variables so that it should not be modified randomly across multiple project files. So that's one of the important use case of static keyword. So here, if you want to compile this project successfully, then you should first remove this because static variables cannot be externed. So that's why you have to remove this and you have to give up this. Otherwise, project will not compile successfully. So static keyword can be used with functions, and we'll see that in the next lecture.